Okay, so number 9, we are going to sketch our cubic graph. Okay, cubic graph and linear graph. So that this equation has 3 real roots, means they are intersect. Okay, equation is how to get, because when we have two graph intersect each other, when we do the simultaneous, we substitute each other, we get this equation, right? We get this equation. So it have 3 roots, means it will have 3 intersection point. From our simultaneous equation, these two graphs intersect together should be have 3 intersection points. So therefore, when we solve the simultaneous equation, we will have 3 roots, have 3x value. Okay, so for first part here, sketching first. Alright, you don't see forward for AB. Here got one part, sketching the graph. For cubic S shape, going up. This linear, you can see positive linear going up also. So this one we have to find when x equals to 0, y equals to -2, intersect, the line intersect at x equals to, y equals to -2. Okay, so our cubic should be a curve. Okay, a curve here, then intersect by a line. So we'll have a line intersect at -2. And then this line gradient should be very steep lah, because you can see 4x. Normally x is 45 degree. If y equals to x 45 degree is 4x, mean it will be going very steep. So that will be your line. So a bit difficult to draw actually. So I draw the line first. Okay, so this is our line going steeper, very steep. Then we draw our cubic. Okay, so we draw our cubic. So our cubic should be a bit, then you can see. Label first. This is y equals to x cubed. The green color is our line. Y is equals to 4x minus 2. Show that it have 3 roots. You can see 3 intersection. So from here we have 3 intersection point. So the equation will have 3 real roots. So that will be our first part of our questions. Then for question A, they want us to figure out. They say, please show that they have 1 in between 1 and 2. So either this or either this. So we can use our algebraic method for question A. Function, we already have, because we have x cubed minus x plus 2 equals to 0. So that will be our function. So substitute 1. Show it again, we have a roots between 1 and 2. So 1 minus 4, -3, -1, less than 0, 2. Eight minus 8, 0, 2, positive. You can follow back the questions here. There's one root, there at least one root of the equation between 1, 2. So that will be our part A. Okay, so make sure when you're drawing your graph, okay, x-axis, y-axis, origin, because here got intersect at origin, we have to label out. Intersection here, we have to label out. Then we can proceed to our Newton-Raphson method. Okay, for question B. Newton-Raphson method, we have to differentiate our function. Function differentiate, power move to the front, power minus 1. Okay, then we can start. Initial value got not, so initial value is 2. Our question initial value is 2. 2 decimal, so 2 decimal plus 2, 4 decimal lah. So x1 is 2, so x2 substitute inside. Okay, function x cubed minus 4x plus 2 over differential function 3x squared minus 4. Calculate for the first value, 2. 1.75. Okay, so it gives us 1.7575. There is no way to find 2 more extra decimal for the answer. So it just follow only. Then continue. We use 1.75 to substitute again. Zero 7. Okay, 2 decimal extra becomes 0.7. Then continue. Haven't repeat yet. Six, 7, 5, 1, 6. So become 1, become 2. Round off, become 2. So you have to still continue because we can't see the 2 decimal that repeat. Yeah, this 6, 8, this is 6, 7, 6, 7, 5. So yes, we can stop already. 513. Okay, doesn't matter for the last. So we can stop already. Because you already repeat now. So you can show, although it doesn't repeat every value, it just repeat the place that we want. So we can stop already. So our x is 1.675. So because of 5, we need to round off 6, 8 for this 2 decimal place. Okay, so we can double check is it correct? We can double check, can have a check our function alpha x cubed minus 4x plus 2 equals to 0. Solve. Okay, yeah, once see here 675. So round off 6, 8 lah. Yeah, correct. So we are doing correctly. So no worry.